So next, I'm going to do problem 4 in the problem set 6.3. So they give you the demand function equal to 85 times 0.975 to the p. And the first question they ask you to compute the consumer expenditure at the price of $30. Right? So this price is the set market price. So here I want to point out this is the consumer expenditure is equal to P0 times Q0, and P0 is the set market price equal to $30, and Q0 is the quantity demanded, which we need to calculate. So for Q0, this is equal to D of P0 or D of 30. And you're going to substitute P equal to 30 into this demand function. That is 85 times 0.975 to the power of 30. Then using the calculator, you get the answer for the quantity demanded. So using the calculator, you will be able to get a quantity demanded of 39.77. You have to be careful with the unit. In this case, the demand function they give you has the unit of 1,000 items. So therefore, the quantity demanded also has the unit of 1,000 items. Now, you're going to substitute the set market price of $30, multiply with 39.77, and you get the consumer expenditure. Using a calculator, you'll be able to get $1193.1 thousand. Once again, you got to be careful with the unit at the end of your answer. Okay, let's move on to part B. In part B, they ask you to calculate the consumer surplus at the set market price of $30. As you remember, the consumer surplus is equal to the integral from 30, which is the set market price, to a P max or infinity. In this case, we still deal with the exponential function, so therefore this is infinity, okay, of d of p dp. So this is the improper integral. To evaluate this improper integral, you have to rewrite as limit as n go to infinity of the definite integral from 30 to n of 85 times 0.975 p dp. Right, one more time. At this point, you can either use the algebraic manipulation or numerical estimation, because the problem didn't specify any particular method, so I'm just going to use the numerical estimation. So you're going to create a table with the first column n, and the second column is the definite integral from 30 to n of 85 times 0.975 to the p dp. And I'm going to let n start at 100, 1,000, 10,000, 100,000, and so on. And please pause the video, try to do this problem by yourself. So here's the result from evaluating the improper integral. As you can see, the value of 1570.8 occurred 3 times. That's why we stopped the evaluations. So the consumer surplus is equal to 1570.8. And as I mentioned, you have to be careful with the unit. And in this case, the unit is $1,000. That's part B. Now let's move on to part C. In part C, the question asks you to calculate the price at which the demand is for the 1,000 items. Right? So we have done this in the previous example, that we're going to set the demand function equal to 40,000 items, but as I mentioned, you got to be careful with the unit. here the unit is 1,000 items, but the unit given to you is items. So you have to change this from 40,000 with unit items to 40 with unit 1,000 items. So that is, you set the demand function equal to 40. Then you use the solver to get the value of P. If you don't know how to use the solver at this point, please let me know. I will show you how to do that during class time. Using the solver, I could be able to get P equal to $29.77. And that is how to solve part C. Now let's move on to part D. So in part D, they ask you to calculate the consumer willingness and ability to spend to purchase 40,000 items. As we did before, the consumer willingness and ability to spend equal to the consumer expenditure plus the consumer surplus. So that means you have to calculate those values separately. Right? First, we're going to calculate consumer expenditure. So for the consumer expenditure, this is equal to the set market price multiplied with the quantity demanded. So the set market price is the one we found in part C, which is 29.77. And you're going to multiply with the quantity demanded. In this case, this is 40,000 items. So using a calculator, I get $1190.8 thousand. This is the consumer expenditure. Next, we're going to calculate the consumer surplus. So the consumer surplus is equal to the integral from the set market price, in this case is 29.77, to infinity. Once again, why do we use infinity? Because we are dealing with exponential functions, and there's no indication they give you the maximum price. So therefore, that's why we have to use infinity. So the consumer surplus equal to the integral from 29.77 to infinity of the demand function, dp. This is the improper integral. You have to rewrite the improper integral in terms of limit of definite integral. That is limit as n go to infinity of the definite integral of 29.77 to capital N of 85 10.975 to the power p dp. So from here, we're going to use the numerical estimation to get the value for the improper integral. Here's the table. The first column is n, and in the second column is the definite integral from 29.77 to capital N of 85 times 0.975 p dp. And I'm going to start n with 100, 1,000, 10,000, and so on. So please stop the video and try to do the problem by yourself. So the result I got right here, when n equal to 100, I get 1313. When n equal to 1,000, I have 1580, and so on. Because 1580 occurred 3 times, that's why I stopped my evaluation. Therefore, the improper integral, or the consumer surplus, is going to equal to 1580. And the unit for the consumer surplus is $1,000. So we just calculate the consumer expenditure and the consumer surplus. Now we can calculate the consumer willingness and ability to spend. For the consumer willingness and ability to spend is equal to the consumer expenditure plus the consumer surplus. These two values you just calculated. This is equal to 1190.8 plus 1580. And using the calculator, I get 2770.8, the unit of $1,000. And that is the result for part D of problem 4. Now let's move on to the next problem.